Welcome to a new episode of my Linux PCI Driver tutorials. Today I want to show you how to write a GPIO chip compatible Linux driver. You may know GPIO chip from your Raspberry Pi. If you list all the device files in /dev, you can find the file GPIO chip 0 and maybe GPIO chip 1. And you can control your GPIOs over GPIO chip with the gpio-tools, gpioset and gpioget. These are bash commands. And the goal for today's video is to make my driver for my Quancom PCI GPIO card compatible with GPIO chip, and this means at the end I can control the GPIOs of my card over gpioget and gpioset. So let's start. Here you can see I'm connected to my PC where I've plugged in my PCI GPIO card, and here I'm already in the source folder for my Linux driver. So here you can see we have the source code for our driver and a makefile to build the source code. So let me open up the source code. So this is the code from my last video where I showed you how to use interrupts with PCI devices, but I've removed all the code which was related to the interrupts. And now I will change this code to make this implementation GPIO chip compatible. So the first thing I need is I have to include linux/gpio.h. Then down here I have a struct which I have named driver data, and I want to rename it from driver data to PCI TTL32IO GPIO chip. And I want to replace this in the whole document. Okay. And now I will add a new field to this struct. So we already have a pointer to bar 0. This is where all the registers to control the GPIOs on this card are. And now I will add a new variable from the struct GPIO chip, and I will call it chip. And I need this field here to store the GPIO chip's information inside this struct here. Okay, then the next thing I will do is I will declare another struct from the type const struct GPIO chip, and I will call it template chip. And here I can initialize some fields. So the first thing I will set is a label. This is the label my GPIO chip will use, and I will use PCI TTL32IO here. And the next thing I have to specify is the owner of this struct, and this is this module. Then I will add some functions to control the GPIOs, but I will skip this for the moment. So I will replace this later. Then the next argument I have to specify is a base. I will set to -1 because I don't need it here. The next value is the number of GPIOs my GPIO chip supports, and here I will set this to 32. And the last argument here is a can sleep boolean value, which I will set to true. So this struct here will contain only information from my GPIO chip, and later I will add the functions to control the GPIO, so I can set the direction and I can read and write them. Okay, and now down here in the probe function, I can now add my GPIO chip. So here I have my struct from the type PCI TTL32IO GPIO chip, my data. Down here I'm allocating memory for this struct. Down here I'm getting the pointer to bar 0 to control the GPIO registers of the card. And down here I will set the chip field to my template chip. And then I can use the function gpio chip add data not GPIO, sorry, this is my data here, my data. And by doing so I have to do this because later when I am in a function, for example, for setting the direction, after having added the chip, I can get the chip's information like the bar back in the functions. And with this call, I do also create the device file under dev /gpio chip 0, for example. And in case this function returns something smaller than 0, an error occurred. So let me copy these 3 lines here. Okay, and the error here is error can add GPIO chip. Okay, so with this function here, what I'm doing here is actually I'm creating the device file GPIO chip and a number. Okay, and I have to do one more thing. I will set the PCI driver data with the function PCI set driver data. So to my device I will set my data here, and I'm doing this because here in the probe and the remove function I have to remove my GPIO chip, and to do so all I have to do is I have to create a struct from the type PCI TTL32IO GPIO chip, and I will call it my data again, and I will set this to PCI get driver data def, and then I'm getting back this my data struct I have initialized here, and in case my data is not a null pointer, I can call GPIO chip remove and remove my data chip, and I can remove the GPIO chip, and by calling this function the device file def GPIO chip and a number will disappear or will be removed. Okay, so now we have added the GPIO chip. I think if I would compile this version I could already see the device file, but now we need to implement the function calls to control the GPIOs. So let's do this, and I will start with the function calls to set and get the direction of the GPIOs. So let me add a function here. We'll call it PCI TTL32IO get direction. This is the function to get the direction of a GPIO pin. The first argument is a struct from the type GPIO chip, and I will call it chip, and it's a pointer, and the next value is an unsigned integer. I will call it offset. This is the GPIO number, or yeah, let's call it GPIO number here because this is a little clearer. Okay, and once again I need a struct from the type PCI TTL32IO GPIO chip, and I will call it GPIO here, and I will use the function GPIO chip get data chip to get back the data, and I need the data to get the bar 0 pointer, and I will need a second value, unsigned 8-bit integer here, and to get the direction of a GPIO I have to read an 8-bit value from my PCI device, and I will read GPIO pointer bar 0 plus offset or PCI TTL PCI, this defined here because this is the offset behind which the state of the GPIO is located. Okay, and now I can return. So in case, or let's do it this way, in case value and shifted by GPIO number divided by 8, and in case value is bigger than 0, we have an output, and in case value is 0, we have an input. In case we have an input, I will return GPIO line direction in. In case it's an output, I will return GPIO line direction out. And why I'm dividing this by 8 here is because I can only set the direction byte-wise. So the first 8 bytes always have the same direction, and then the second, and then byte 9 to 15 has the same direction, and so on and so forth. And the return value here is either GPIO line direction out or GPIO line direction in. Okay. Good, now I need some functions to set the direction. PCI TTL32IO set direction input. I will use for inputs. The arguments are the same like here, so let me just copy these 3 lines here. And let's delete this here. So the arguments again is here a pointer to our GPIO chip and the GPIO number we're interested in. So I have declared this value byte here, and down here I'm getting the chip's data. Okay, and to set the direction, what I will do is I will read again this here. Then I will clear 1 bit. So 1 shifted by GPIO number divided by 8. And then I can write this back. So I want to write value, and I want to write it to the GPIO direction, and then I will return 0 here. Okay, so if I'm setting this bit to 0, for example, if I have GPIO number 9, I will set bit 1 to 0 here, and then GPIO 9 to 08 to GPIO 15 are inputs. Okay, I have to do the same thing for the outputs. But here we have one more argument. We have an integer for the value, because we can set the value initially when we're setting this to an output. So let me copy these 4 lines here. So once again, I am reading the direction register, and now I will need an OR to set the corresponding bit. Then I will write this back, and then I will use the function PCI TTL32IO set to set the value. And of course, this function doesn't exist yet, so I have to create it. Okay, so now we have created all the functions to get and set the direction. Now we can write the functions for setting the output and reading the inputs. So let's start with setting the outputs. So the first function I will define is PCIO32IO set multiple, and with this function I can set multiple GPIOs at once. The arguments once again are GPIO from the type struct GPIO chip pointer, and I will call it chip again. The next argument is from the type unsigned long mask and unsigned long bits. So with the mask, I'm getting all ones except the GPIOs I'm interested in. And bits contain, this pointer bits here contains the bits I want to set. But when I'm implementing the PCI GTL32IO set function, you can see what these two arguments mean in a little bit more detail. So once again, I need my PCI TTL32IO GPIO chip struct, and this time I will use a 32-bit unsigned integer here. Okay, so the first thing I will do again is I will read 32 bits and I will read GPIO pointer bar 0 plus PCI TTL, and this time I want to use the offset GPIO state. So this is a pointer to the state of the GPIOs. And then I will do the following. I will AND this value with the value behind the mask pointer, and I will OR it with the bits. And then I can write it back to the bar. Okay, and this is a void function, so I don't have to return anything here. And now let me implement PCI TTL32IO set to set a single pin. In this case, the arguments change a little bit, so we have once again our GPIO number, and we have the value for the GPIO. So I will declare two variables here, a mask and bits, and I will set both to 0 initially. And now I will do the following. The mask is 1 shifted by the GPIO number, and bits is, and this should be an unsigned long, so I don't have problems with the type. And bits should be, and I have to AND it here, or invert the bits here. And bits are the value shifted by GPIO number. And then what I will do is I will call PCI TTL32IO set multiple here. I'm passing the chip, I'm passing the mask, and I'm passing the bits. And this is a void function again, so I don't have a return value. And here you can see what the mask is. So in the mask, we are setting every bit to 0, so we can clear it. And here in the bits, we have the value here. Okay, so last thing we need are the functions to read the GPIOs. This time they have a return value from the type integer. And I will start with the get multiple function once again. The arguments here are a pointer to our GPIO chip. Then again the mask with all the bits we are interested in. And the bits will be the result here. Okay, so let me copy these 3 lines here. So our value, we can copy this too here. Okay, so here we are reading the GPIO state back once again. And here in this case, bits is equal to value and mask. And then I will return 0 here. Okay. And now I will implement the get callback here. So this will be get, and this is an integer. Okay, so this looks okay. The mask now should be 1 shifted by GPIO number. and then we can call the function PCI TTL32IO get multiple. I'm passing the chip, the mask, and the bits, and then I will return the GPIO state. So in case bits is greater than 0, I will return a 1, else I will return a 0 here. Okay, now I have declared all the functions, so now let me add them here in this struct. So the first is get direction, TTL32IO get direction, then set or direction input PCI TTL32IO set direction input. Okay, then we have direction output is equal to TTL32IO set direction output. Set will be PCI TTL32IO set multiple is equal to PCI TTL32IO set multiple, and let's copy these two lines here for get. Okay, and this should be all the functions. Okay, so now let me try to compile this program here. And let's see how much mistakes I've made. Okay, PCI, I haven't declared get. Okay. Really? PCI get. Okay, let me pause the video for a second so I can find the error. Okay, well, the error is quite trivial. You can see this third argument here. There are just two arguments because a value doesn't make sense for getting the direction, so we have just the GPIO chip pointer here and the GPIO number we're interested in here. So let me try it once again. Okay, it looks good. So I will become root user now, and then I will try to load my module. Okay, so loading worked. And if I look into def, I should see GPIO chip 0 here. Yes. And if I do a GPIO detect, I see I have here a GPIO chip 0 with 32 GPIOs. And now if I do a GPIO chip 0 and I want to set, let's set GPIO 5 to 1. Yeah, this LED stays off and the other two turned on, and this is okay because the LEDs here are wired in a way that they are on when they are set to 0. So if I set 5 to 0 and 6 to 1 and 7 to 1, only this GPIO here is on, and now let's set 5 to 1 too, so everything is off. Now let's try reading the GPIO. So this is GPIO 0, 1, 2, 3. And if I press the button, I should get a 0, so let's try it. Yep, and if I release the button, I should get a 1. And let's read the whole row here. So let me press this button here, so I should get 1, 0, 0, 1. Now I should get 1, 1, 1, 0. Yeah, it works. Okay, so we have successfully written a GPIO chip compatible driver, and we are able to control it over the gpio-tools bash commands. So I guess that's it for today. I hope you've enjoyed the video and learned something. In case you want to support my work, you can buy my coffee on buymeacoffee.com/Johannes for Linux. So that's it for today. Thanks for watching and goodbye.